Hey everyone, welcome back. And today we'll be doing another Leetcode problem 703 kth largest element in a stream. So stream means that the input is coming and we have to return the output likewise. And this is an easy one. Design a class to find the kth element, largest element in the stream. Note that the kth largest element in the sorted order, not the distinct element. Basically saying that there can be duplicates, and implement the k class, the constructor with the k and the nums, and we have to add the values, function which can add the values to our uh, data structure which we are going to use to solve this problem, and give us the kth largest element in the stream. So that's it. So what they want us to do, if we have an example where 3 is the k largest element, and this whole thing is going to be our array, a nums list, in which we are going to return the kth largest element. If it is 3, then we are going to return the third largest element, which is 4. And the other functions, which other, you can say, operations which we are going to do, and we can use an array in which we can just sort, add and then sort. But we can also use the min heap, which is more efficient in this problem, because we can just let's say self dot min heap, call it min heap, alongside the self k. So the min heap will be equal to the nums, and the k will be equal to the k which we are being provided with. In this case is 3. So we will just convert this min heap into a actual heap. So heap dot heap phi self dot min heap, self dot min heap. Okay. So now length, we will take the maximum length of min heap and just pop it until we reach the k element, because if we have the k element, for example in this case 3, then we know that we are going to have the third largest element at the very top at the 0 index. So min heap, if it is greater than k, self dot k, we are going to heap q dot heap heap pop another p. Okay, in the self min heap. Okay, we are done with our constructor. At this point, we have to have, you can say, a three elements in this, you can say, in this specific case in our min heap, if there are more elements. So now we have to add more elements, which we are being provided 3, 5, 10, 9, 4, and we will just push them. So heap q dot heap push them with self dot min heap alongside the value. And now we will see if the length, because at this point we do not want to pop, because there can be less element than k, we have to check. And there is no if, we are going to, I just saw it, there is going to be a while, because we have to pop until there are less than or equal, there are equal to elements left, equal to k elements left in our min heap. So if the length of the self dot min heap is greater than k, only then we are going to pop. So heap q dot heap dot pop with the p. Okay, so self dot heap, and after that we can just return the self dot min heap at the 0 index, because we are sure we have uh, k elements, which in this case are going to be 3. And in any case, we will just have the minimum elements at the very top, and it will be like accessed by 0th index, because at the very top we have a 0 index. So k is not defined. Yes, this was the class instance, so let's use self. Okay, this works, and let's submit it, and then we will see how this whole thing is working. So we have the input like this. Okay, yeah, in which this is the k, this is the nums, and all other remaining part is just add. This whole thing is just the elements which we are going to add in our heap. So starting from 482, 482, yeah. So the k is 3, k is equal to 3, and now we have said that if we have elements more than k, then we are going to pop it. So basically we are going to pop 2 at this point, because 2 is neither our, you can say, the third largest element, and it is, you can say, exceeding our limit, which is going to be 3 in this specific case. So pop 3, pop 2, and now we are going to add 3, like this 3. So this 3 will be added to our heap. So our heap will at this point is like 4, 5, and it has 8. So we can see that this 3 is neither our third greatest element, and it is just exceeding the, you can say, the limit, which is the k. So we will just going to pop it, and it is never going, the only element which we are going to have at the top is the element which is going to be less than 4. So this is just basically at the very first in our heap, but we are going to pop it because obviously, again, I'm saying it again, like this is exceeding our limit. So at this point we are going to return our 4. Like you can see here, if we add 3, we are going to return 4, because 4 is our greatest, third, not the, not the third greatest element, but it is also our kth greatest element, which can be, k can vary. So we have 4, 5, 8 in our heap now, and we are going to add 5. So if we add 5, then this 5 is going to be at the location here. Now the min heap will reset itself, because it will become like 558, and we are going to pop if we have more than k elements. So we'll be removing 4 in this case, and the head will become, at the very first, you can say, we are going to have 4. So we are having 558, and now we have the kth greatest element in our stream, which is equal to 5. Now we are going to add 10. So 558, it is 10 being added. So if we add 10, then we know that it is going to be at the very last, because it is the greatest element. And then we are going to pop the very, you can say, the very top element, and which is in this case is 5. So we are going to return 5 in this case also, because the greater element still is 5, the greater k element is still is 5, and we have to update our min heap, which will look like this at this point. So now if we add 9, so our min heap is like this, and if we add 9, then we know that this is going to be added at this place. Okay, I just messed up, like, okay, 9. Okay, so the length is going to be increased by k. So we know that we are going to pop the very top. So the 5 will be popped, and now at this point we are going to return 8, because 8 is the kth largest element. So our min heap will look like this: 8, 9, 10. Now we are going to add 4. So our min heap is like 8, 9, 10, 4. So this will be just added at the very first, and it is also going to be popped, because the length is going to be exceeded by k. So, and this, in this specific step, we are going to be also returning 8, because 8 is the kth largest element in our min heap. And that's it, you can say 4, 5, 5, 8, 8. This was our whole output, and this was, like you can see in this part, this is going to be our whole output. So that's it.